Welcome back. In Module 5, we'll talk about deploying cost-effective storage, as well as some of the underlying networking technologies that will help to assist to really maximize how you can leverage some of these new storage options that have become available in the Windows Server 2012 product family. So as we take a look at the scenario, what we've got here is Contoso wants to take a look at leveraging SMB-based file storage because this is really the majority of their internal file storage requirements. And the fact that SQL Server and virtual machines can run quite happily off SMB 3.0 file shares, it's an area that Contoso has decided to start investing in. Now, what they want to do is start extending their storage infrastructure, but not going down the path of some of the expensive SAN solutions that they've been guided towards in the past. Because what they found was that they were getting good solutions, but the cost per terabyte or the cost per gigabyte was really a lot higher than what they really wanted to be paying. Now, they do have some ideas. They want to start taking a look at some of the JBOD enclosures that are available. They want to see how they can actually just leverage some, industry standard hardware without really being pushed down a particular vendor's hardware path. So what is it that they're looking at doing? Well, with the new servers they're making sure that the new servers have got multiple 10 gigabit Ethernet adapters included, which, for a typical SMB today is probably not something that they're really thinking about doing. But as we start thinking about the direction in which things are heading, this is really the kind of thing that we know at some point in time is probably just going to be one of those default options. The same way that we've moved from 10 meg to 100 meg to gigabit, the move to 10 gig is something that we know will happen over time. Now, what they also want now is the ability to easily start provisioning this storage out without it really being a huge admin overhead, without having to learn any new kind of, new set of tools from different vendors with an interface that they're not used to. They want to be able to use some of the existing skills that they've got, so they know how to use PowerShell. So they want a solution that they can just jump into a PowerShell window and start doing what it is that they want to do to make this storage act the way that they want to. But if they've got newer people who aren't familiar with PowerShell and just want to use the GUI tools, obviously they can do that as well. Now, as we start taking a look at the Microsoft storage vision for cloud deployment, it's really about taking basic storage and just expanding it out. So if we start adding the different tiers, what Microsoft wants to do is take those physical disks and start abstracting them out from what's actually happening and what's being presented to the users or the servers. So this is the kind of thing that I guess in some ways, if you think about what RAID does today, RAID doesn't show you what you've got, it shows you what it wants you to think you've got. So it's a similar thing here with storage spaces, but we start getting a lot more flexibility here, and you'll see some of the flexibility come through in the next slides when we talk about some of the additional capabilities that this provides over your traditional RAID-like capabilities. So what we're really starting to get here is the ability to have SAN-like capabilities, but just being something that Windows Server includes out of box. So in this case, what we're talking about with this slide is a situation where a customer may want to have multiple file servers available, but they want to distribute the load over them. They really want this to start scaling out. So for large SQL databases, for large Hyper-V deployments, this may be something that that may be relevant for some of your larger customers today. And for those who are looking at expanding in the future, is probably something you really should be thinking about. Now, what we have sitting on top of this is, we're not necessarily just talking about scale-out file server from the traditional file server. This is where me as a user keeps my shares. We're talking about this as a scale-out file server cluster, for example, that's available to a number of maybe a single or maybe multiple Hyper-V servers. It may be SQL servers sitting on top of that. And what we're just using as that layer in between is the SMB protocol. So we've spoken a little bit about the SMB protocol during these modules, but in this one we'll dig in again because there are some points of SMB that really helped this scale-out file server story as well. So let's take a look here. So first of all, when we start working with storage spaces, which is the new technology that Microsoft has introduced, what you've got here is the ability to start adding physical disks into the environment. So it might be your traditional mechanical hard drives, it may be SATA or SAS SSDs, it may be PCI Express SSD devices, for example. And the idea here is that you can mix and match the types of storage to start getting this tiered physical storage. But now you start getting storage virtualization. So Storage Spaces provides this. You get storage pools in which you start building out your virtual disks. And during the demonstration, I will go through and show you how to do this, including if you don't have an environment where you can play with mechanical and physical drives, how we can use a virtualized environment to actually simulate the SSD tiered caching experience as well. So the data is automatically tiered across memory, solid state, and spinning disks, and there's a write-back cache that's automatically set up on the SSD tier so that any kind of peak workload, so it may be a SQL database that occasionally has a huge amount of write traffic coming in from lots of locations, and in this case think of the SSD tier as something that can absorb that buffer and then write it back. So if we talk about IOPS, for example, as a performance of disk measurement versus just pure read and write speed, this is an area where SSDs are hundreds of times better than what your best mechanical drives have got. Now, we can introduce things such as mirroring, we can do parity. So some of the things that you're familiar with from a RAID terminology perspective do also apply, but think of it in terms of here you've got no reliance on any particular RAID vendor's capabilities. This is something that it's the OS itself that's providing these. Now you can do thin provisioning, and you've also got support for trim. You've got integration with other Windows Server 2012 capabilities, so you'll see that this just integrates directly into Server Manager, and you'll see that things such as Hyper-V, etc., just leverage this very, very easily. Now, when it comes to what exactly is it that you can attach to this? Well, if you're talking about storage spaces from an enterprise perspective, most of the time you're probably going to be looking at things such as SAS. But you do have SATA options there. You do have PCI Express options as well that I mentioned. Even if you're looking at this from a consumer perspective, or even just from your own dev and test lab environment, it's not going to complain if you plug in external USB drives. Just make sure the USB 3 so that the performance stuff doesn't get hit too much by the speed of the interface. So as we start building on top of this, we can start taking those different groups of storage devices, we can include them into these storage pools, and then, as we saw in the previous slide, we can now start creating storage spaces on top of these. So this is that virtualized storage. Now, the Windows Server 2012 R2 capabilities that can take advantage of this, we've got SMB Direct, which we've briefly discussed, but we'll cover in a little bit more detail as we go through this module. As we've already mentioned, Hyper-V is really one of the big drivers of this whole storage story. And the other capability that leverages this quite well is the SMB multi-channel. So I've included an SMB multi-channel demonstration so that you can get an idea of just, if we've got more throughput on the disk side, are we going to be limiting ourselves if we've only got single gigabit connectivity, for example, in an environment? Now, once we get to the application server or the file server, these are either physical or virtualized deployments. So, we may have a virtualized SQL server that's sitting there, or it may be a physical Hyper-V box that sits there. It doesn't really matter as long as they're on the network. They can connect through during using SMB. So let's take a look at the scenario now. So, what's happening with Contoso is that they want to invest more in faster storage, and the current solution they've got has only got 25 gigabytes of tier 1, or that is SSD storage, and it's set to auto tier but only for one SQL server instance. And what they're finding is that they've seen the benefits of tiered storage in this example, but that 25 gig just isn't enough. It barely copes with that one database they wanted to support, yet alone the other temporary databases that they need. So they don't have the budget to go through and expand the traditional storage infrastructure that they've gotten from their SAN vendor. So instead they want to take a look at something that will give them better analytics performance and will sort of really help smooth things out. So if there is a big workload that creates a lot of disk activity, in this case it's something that they want an SSD tier that will actually scale out to support that and reduce some of those the times that it takes for long-running queries. So as we start looking at the hybrid storage pools and tiered storage, what we have here is The SSDs and the hard drives operate as different tiers in the pool, but together they appear as a single disk. So it's a solution where if you've got, in this case, if we take a look, we've got 8 hard drives. So if we assume that each of those hard drives is 1 terabyte, and we assume that each of the SSDs, it looks like there's 4 of them, is 256 gig. Think of this as 4 times 256, so that's 1 gig plus 8 times 1 gig. So think of this as total, it would give you 9 gig, or actually we shouldn't say 9 gigabytes, 9 terabytes is a much nicer number. Sorry for that. So effectively, it's not saying that the SSDs are keeping copies of the data. It's a matter of the SSDs are keeping the data as well as the hard drives. So effectively, it's something where it's the total amount of space you add into a storage pool is the amount of space that's available. So Windows will automatically tier the data across this based on patterns of usage. So it's running in the background, watching to see what happens. And it tracks data temperature. And what do we mean by data temperature? Well, this is something where it's not looking at a file to say, are you a hot file or a cold file? It's looking within the file. Because if it's only a 4K file, okay, well, it doesn't really matter if it's the whole file that's hot or not. It's not going to really take up much storage space on the SSD tier. But if it's a 4 terabyte file, you don't want that whole 4 terabyte file moving because it may be a 4 terabyte SQL database, but it may only be a couple of hundred meg of that database that is actually used frequently. So it's only those hot regions that get moved to the SSDs, and the cold regions can reside on the hard drives. Now you can also choose to pin files. So you could say, well, look, these are VHDs that I know that if a user comes in the morning, this is a VHD that if they're going to start it up, that I want it to run at full performance right from the beginning, then this is a good idea to pin this one straight into that environment. And realistically speaking, if the SSD is something that's getting used quite frequently, the chances are it's going to be up in that tier, unless there's other higher priority traffic. But by pinning something, it means that you've taken control over that. Now, tiered storage, it will honor those pinned files before trying to add anything else into that SSD storage. So it's not going to bump out your choice because it thinks it's got better ideas. In this case, it's a matter of what you decide to pin is what actually stays in there. So we've spoken about some of this in a small amount of detail, but let's take a look at the traditional way that things may have been done in a Windows Server environment where someone may have been running Hyper-V or SQL Server, for example. And in the they may have had some kind of scale-out storage solution, but in the past it was it was probably some kind of custom RAID array from the hardware vendor that you work with, or maybe you've got your own preference for RAID controller cards. It may have been being distributed via clustered shared volumes, but the beauty though was that it was still being presented by this single file system namespace. So you just use that one namespace to get access to everything. But what we've started seeing now is that we can start doing things like we can put the file server cluster in front of that, so everyone gets access to that single share. But now above that, what we've got is that things such as a Hyper-V cluster or SQL Server clusters, for example, they can come through and connect out to these, what traditionally would have been RAID arrays that were sitting there behind the scenes somewhere. Now, as time's progressed, what's happened is those RAID arrays have started moving more across to dedicated type storage area network devices. So depending on what hardware vendors you work with, you may have a preference for one or the other. But what Microsoft's trying to do here is present another alternative. And they're not saying throw out your SAN devices. They're not saying leave them behind and move wholeheartedly to storage spaces. Instead, they're saying pick and choose the right solution for the customer and for that particular workload. So in this case, storage spaces can very easily step in and start taking the place of some of those other solutions that are there. So this still gives us some of the, all the same capabilities as we've seen in terms of, that highly available shared data store for SQL databases and your virtual machines. Once you start working with storage spaces, this will give you things such as, as I mentioned earlier, the ability to use PowerShell to do configuration if that's an area of your expertise. Alternatively, just use the Server Manager tool that you'd be using to perform a lot of other tasks for day-to-day management of your Windows Server environments. Now, other things here is that it can work alongside existing storage investments. So as I said, it's not a rip and replace approach. Pick and choose where to use storage spaces alongside what you've already got. Now, as we start taking a look at some of the other capabilities that are required to really help this work, if we take a look at this, it's not really something that you want each of the Hyper-V cluster machines or the SQL server, for example, you don't want each of them sitting there on a single connection. You want to start doing things such as having the ability to have transparent failover capability so that if one of the connections falls apart, so it may be something where it could be a NIC dies, it could be that a switch dies, it could be that someone accidentally unplugs something, and we've never seen that kind of thing happen in the real world at all. But in this case, what happens is we get failover transparency. So I can unplug the cable, and what will happen then is it will go through and, it's operating normally. Whatever it is that kicks off that issue can now go through and be automatically redirected through to that other connection. So these two connections are basically sitting there in an active-active type situation. So this is one of the the big benefits that's been added in SMB 3.0, and what we'll do is we'll jump into a demonstration shortly for storage spaces and storage pools, but then after that we'll come back in, we'll talk a little bit more about some of the other SMB capabilities, and the demonstration will include showing you SMB transparent failover in action, so you can actually see it working in a real environment. So now let's jump into the storage spaces and storage pools demonstration. Jumping into Server Manager, once we navigate through file and storage services and into volumes, we can see here that we don't have a storage space or a storage pool created yet. Instead, what we've got is the primordial pool, which is effectively where we've got all of these disks which have yet been really added into the system officially. So even though the disks are connected, we're not actually doing anything with them yet. So they're not formatted, for example, they don't have any files on them. Just think of them all as raw disks that we've just attached directly into the system. So the first thing that I need to do is go through and create a new storage pool. And in this storage pool, we'll keep things very simple to begin with. We'll just call it pool 1. And where's it pulling them from? They're from that primordial pool. Which physical disks? And in this case, we want to include all of the physical disks. And what we can do here, when we take a look at allocation, we can do things such as set them up so that they start manually, for example. We can set it up as a hot spare. We could have it automatically included. And for the sake of today's storage spaces content, we just want to keep that as automatic. And I'll click Create. And now this will fairly quickly go through and create that storage pool for us. Now we can see here, once we go to the storage pool, one of the things that's important here is that it's not actually able to determine at this point, because I'm running in a virtual environment, it can't determine which of these drives are supposed to be SSDs versus which ones are supposed to be mechanical drives. And what you can probably tell by looking at these is the ones that are 511 gig, or technically 512 gig, they are SSDs, which I want to use for tiered caching, whereas the 4 terabytes drives are the mechanical drives. So before I proceed any further, because if I try to set anything else up from here, it's not going to be able to take advantage of these being SSDs in some cases. So what I can do now is run a PowerShell commandlet, which is get storage pool 1, and then get physical disk where the size is less than 600 gig. So obviously I don't need to make it as high as 600 gig, it's just what I've done for the sake of safety in case there may have been some 550 gig drives or something like that were SSDs as well. And then what I need to do is set the physical disk media type to SSD. So if I do that, that's done. Now let's just quickly jump back to Server Manager. And if we hit refresh, what we'll see here is that the 2 smaller drives are now set as SSDs. Now, while there really isn't a requirement for me to go through and set the other 3 disks as mechanical drives, because it will treat them as mechanical drives anyway, what I can do here is just make some slight adjustments to that PowerShell commandlet that I ran, and instead of it being less than 600 gig, we'll make it greater than 600 gig. Instead of being SSD, we'll change it to HDD. And now when we go back in and refresh that, we'll see that now everything is the way that it should be in a physical environment. So this is just a good way to sort of get an overview of if you are in a situation where you are using some kind of SSD device that for some reason isn't reporting itself to Windows as an SSD, you can use PowerShell to override that. Or in this case, even if it's all mechanical drives, or if it's all SSDs, or it's all virtual drives, which it is in this environment, we can just do this override just so that we can actually test it and see the way that we can actually set up the tiered storage. Now, what I'll do is start the new virtual disk wizard, and before we begin, let's just go through which storage pool. We've only got one pool, so that's easy to kick off with. And we'll call this one Virtual Disk 1. We're being very creative with the names today. We won't worry about a description because we're not going to be keeping this long term. Now, what we can see here is that the storage tiers on the disk can be created automatically now because it has created these it has detected the SSD files. So this means that things like the SSD write-back cache, as well as the automatic allocation of hotspots of files or pinned files into the SSD storage tier, really starts accelerating different workloads. So now let's click on Next. Do we want to make it simple or a mirror? In this case, we're really talking about something that's backed up regularly. We may have copies of the data sitting on other disks elsewhere in the environment. So we'll keep it as simple. That way we can get striping across the physical disk. Do we want thin provisioning or fixed provisioning? In this case, because we're using storage tiers, we can't do thin provisioning. But if you think about an environment such as if you need to set users a certain amount of space for their personal document storage, for example, you may make it appear to each user that they've got a certain amount of disk space, whereas in reality you don't have anywhere near that amount of disk space. And that allows you to gradually increase physical capacity as the real capacity matches that. Now for the sizing, let's just make the SSD tier the maximum size. We'll make the standard tier the maximum size, and this will go through and make it 13 terabytes, which was the total that we saw at the top. And then once I go through and click Create, this will just go through and now give us the option to create that volume. So we do want that volume to be created automatically here. Now, before we begin, so what do I want to call it? So first of all, in this case, when we're talking about the volume, we're talking about creating volumes on a virtual physical disk. So the same way that we could do partitioning on our own physical hard drives, think of this volume creation as the same type of thing. Now, I want to just create an entire volume. I don't really want to go through and start separating things out. I can create additional storage pools later where I do that. Now, do I want to give it a drive letter? E seems like a good letter, so we'll keep that. What do we want to do with the file system? Well, I'll call it E drive. I don't want to generate short file names. Now, what we can do in here is we can either use NTFS or REFS. So REFS is Microsoft's next generation file system, the resilient file system, which has got a lot more fault tolerance capabilities built in. So it's the longer term successor to NTFS. But for now, we'll stay at NTFS because we know that's what our applications are going to work well with. And then I can go through and click Create. And then that's really it. That's everything that's required for me to go through now. And I've automatically created this tiered storage environment. So hot data will automatically get moved there. Databases or other files that I decide I need to pin into that storage tier can move there. And it's something that happens automatically for high write-back workloads or that happen in short bursts. The SSD caching tier can also really just act as a really big buffer to, take a huge number of IOPS at the same time and then gradually write those back to the mechanical drives as they're not required. So overall, you get some pretty big speed improvements, in this case just from getting a couple of smaller SSDs and loading them into your environment. Now that we've taken a brief look at storage spaces and storage pool creation, let's jump into the next scenario so we can see what else that Contoso need to do inside of their network to help with this overall solution design that they're working towards. So what they've got here is that they want to be able to go through and start increasing the capacity so they can start having more virtual machine deployments. So there's a lot of different workloads that they've got that they still want to virtualize. There are new things they need to add. There are old physical instances that they want to migrate across. But what they want to do is optimize the virtual machine stores so that base images and differencing disks, for example, are not having the overall impact in terms of just being storage hogs and constantly growing to take up more disk space. Because if you think about the realities of what's going on here, if you're basing multiple virtual machines on the same base operating system install, for example, then there is a lot of redundant data across all of those. So the base operating system install, for example, is going to take up a large part of that overall space. So you've got a lot of duplicated space inside each of the VHD files here, for example. So what they want to do is make sure that they're also ensuring the fastest connections possible between the Hyper-V host and the file servers that are storing the VHD files. And they also need to make sure that this SMB failover and resiliency is also going to be something that can be taken advantage of here. So when we do start looking at the data duplication capabilities, what we find here is that general file shares get just over a 40% saving. But as we start moving up to things like software deployment shares, VHD libraries, and then operating system VHDs, all of a sudden we can see that we can really start claiming back large amounts of storage space. So even if you think about situations where you may have an operating system VHD, the example that I used where, if it's a whole bunch of different instances based on Windows Server 2012 R2, regardless of whether we're talking standard or data center, then it's going to be almost unique file, a lot of unique files, sorry, not a lot of unique, a lot of common files across the multiple VMs. So you can really start saving a lot of space. Now, a VHD library also have those benefits. You also got a lot of benefits on software deployment shares, as you can see, because a lot of the time you'll find that there may be quite a few common components that are used across different installations from the same vendor, for example. So if you've got different ISO files for the different installs of different Microsoft Office products, for example, you'll get amazing storage results from that, because you'll find that there's a lot of redundant data across all of those different ISO files, for example. So when we start taking a look at how we can really start scaling these types of things out. So for customers who are looking at things such as gigabit or 10 gig Ethernet and saying, it's not quite fast enough, we really need something that is just not going to get in the way of the performance of what we want here, then we can start looking at things such as SMB Direct. So we've spoken about this previously in an earlier module, but the whole RDMA or remote DMA is all about getting very, very high performance networking. So effectively we're working at the speed of the system memory between the two servers. So we're doing in-memory copies from one server to another. So it's very low latency. It takes advantage of technology such as InfiniBand and iWarp, which gives 40 gig or 56 gig of throughput, for example, and works incredibly well for both small and large I/O workloads. Now, this is also compatible with SMB multi-channel. So, so these benefits keep stacking up. So in the case of RDMA, what we can do here is if someone says, look, I'm investing all of this and I can get great performance, I don't need better performance, but I need to make sure that things keep working, that you can go through and start doing your SMB multi-channel across these as well. So what we can do here is we're basically shooting information straight through here from the SMB client on the file client through to the file server. So obviously we can skip some of the overhead that would normally be introduced, as well as take advantage of that much higher bandwidth bus. Now moving to SMB multi-channel, this is really just about the automatic detection and use of different paths to get from point A to point B and from point C to point D. So if we take a look at the diagram that we've got here, we can use multiple network connections between the client and the server. So just dropping in another NIC or a multi-port NIC, for example, if provided that your switching infrastructure, for example, can support it, all of a sudden you'll start doubling, tripling, quadrupling the bandwidth that you've got between the server or between the different servers, for example. So it also helps server applications to be resilient because it supports the SMB failover capability or the transparent failover. So that bandwidth aggregation just happens automatically. So this is one of the things that catches people off guard here is that they're looking for options as to where do I enable it, where do I configure it, and to enable it, you just add network adapters. You can do some tweaking and some optimization through PowerShell, so that if you do decide that you don't want this card, for example, or this NIC, for example, to be participating in SMB multi-channel because you want it focused on something else, you can do that kind of thing with PowerShell, but generally it's something where it will scale up and down as required. Now, it is automatic configuration with very little admin overhead. So, it's one of the things when, if you've been used to situations where you've had to go through and make a lot of decisions when it comes to setting up things like NIC teaming in the past, and you've had to go through and do your router or switch configuration, this is the kind of thing where basically you can say goodbye to that and just drop the cards in, hook up more cables, and away you go. So with the file copy, it basically gets broken up and sent across the connection as multiple pieces. And in the diagram that in the demonstration I'll do for you shortly, what you'll see is just this in action, where I'm not doing anything special. I don't need to kick off multiple file copies to populate each of those network connections. Instead, it will just split the load across two adapters, and this is something that just can keep scaling up. So now that we've seen theoretically how this works, let's jump into a demonstration. And in this demonstration, what I'll cover are three different things that work very well together. So from the SMB 3.0 perspective, first of all, ODX, which is the offloaded file copy capabilities. So you'll see me do large network copies from my local device that don't have any impact on the overall network. I'm effectively going to be doing a copy from a server's one disk array on a server to another disk array on the same server, and there's no real impact on my local machine because it's not doing anything apart from issuing the request. Then we'll see the SMB multi-channel in action, and I'll just show you some simple ways to monitor it and see that it actually works. And then the final piece that we can dig into is transparent failover, and the easiest way to show transparent failover is to actually just disable one of the network cards. We don't even need to unplug anything. Just disabling one of the network cables will do, the network connections will do that. So instead of talking about it, let's jump in and let's take a look at some of these great capabilities that were introduced with SMB 3.0. In this demonstration, I'll cover SMB 3.0 capabilities, including ODX, so how we can do some high-speed file copies without having a network impact. Multi-channel support, so how we can start scaling out our SMB-based traffic, as well as transparent failover. So working together, these three capabilities start giving us some great capabilities to scale out workloads such as our Hyper-V and storage requirements to really take advantage of the network infrastructure that's in place and make the most out of the virtualization infrastructure that we're also getting our customers to invest in. So let's start here. If we take a look here, I've got two shares open on the same server, and these are on different spindles. So what we can see here is if I make a copy of this and now paste it across to the other machine from my local machine, first of all, we'll see that from a network performance perspective, it's happening a lot faster than what we could normally do over our typical gigabit type connection. But what's also important here is when we take a look at the network activity, you'll see that even though this machine has got two Ethernet adapters, they're not actually being impacted by this activity whatsoever. It's really a matter of this was a command that was sent to the ODX capable file server, which in this case is a Windows Server 2012 R2 machine, and it can actually offload that file transfer for us. So first of all, you can see that there's really no network impact, but secondly, that it's also operating at a much higher speed than than a gigabit Ethernet, for example, or even in the case of this machine, then two multi-channel SMB connections can give us. But also it's not placing any kind of real CPU or I/O stress down on this local Hyper-V machine either. So obviously there are some benefits all around with this. Now, the next thing that I want to do is copy that file from that location that I just moved it to, and now I'll just copy it to my local machine. So again, we'll use some of the same tools here. I'll just copy and paste, so copy and paste. And what we can see here is instantly that this is occurring faster than gigabit speed. So if we take a look at what's happening here, just let me go to the right screen. Sorry, I need to go back to Task Manager, which I accidentally closed. What we can see here is that it's basically splitting the load across both of these. So now let's just close that, or minimize that, and I'll disable one of the NICs. Now obviously if one of the NICs is disabled, we're going to see, first of all, that it will disappear from Task Manager because it's no longer available. But what we'll also see, though, is that the network throughput will start falling because it doesn't need to, or because it can't go across that second adapter. So this is SMB multi-channel kicking in and realizing that the connection has dropped, and it will gradually start building back up to where it was. Now, what I can also do from here is I can go through now and enable this connection, and what that will do is instantly start aggregating that bandwidth back together again. So it'll take a couple of seconds for it to do that, but what you can see is that it's quickly picked up the load, and all of a sudden it's starting to copy back up across gigabit speeds once again. So that gives you an indication that even though we've gone through, we've interrupted the process, we've disabled a NIC, that it can go through, that transparent failover kicks in, and we can see that that load balancing across multiple network adapters kicks in, and eventually it starts getting back up to those dual gigabit speeds that we had, because we do have 2 gigabit Ether adapters in this machine. That brings us to the conclusion of this module. Hopefully these demonstrations have given you a good understanding of some of the different things you can do now with Windows Server 2012 and 2012 R2 that weren't available in previous versions of Windows Server, to really start helping you build out virtualized environments and high-performance networking and high-performance storage solutions that really scale to meet your customers' requirements.